All right, here we go. We're on to topic 2, lesson 2, which is on waste mitigation. So, we create a lot of waste. What are we going to do about it? How are we going to get better? The essential idea, waste mitigation strategies can reduce or eliminate the volume of material disposed to landfill. Back when our population was a lot smaller, because we're really approaching 8 billion now in 2020, I think 100 years ago when we were just about 1 billion, maybe 1.5 billion. It's a very different population on the world right now. Closed loop recycling. Designing out waste and designing for closed loop recycling will be more important as resources become scarcer and waste becomes more expensive. What that means, instead of designing a product that is meant to be used and then disposed of, you're designing a product that's meant to be used and then disassembled, recycled, and reused again for something else. Dematerialization. Although that image on the left looks really cool, that's really not what it's about. The whole goal is to look at the materials we use, figure out how to use less different materials so they're more recyclable, and figure out how to use less materials overall. The United Nations Environment Program has this statement: the reduction of total material and energy throughout any product or service, and thus the limitation of its environmental impact. Dematerialization could be using less raw materials, the production, less energy and materials while you're using the product, and creating less waste at the disposal. Dematerialization can be implemented at many different steps in the life cycle of this product. So again, similar to what we just said, during the material extraction, having an eco design, cleaner production during the manufacture, environmentally conscious consumption patterns, so while you're using the product, and when you're done with the product, recycling it. Oftentimes, dematerialization will mean smaller, lighter products with less stuff in them. And the stuff that is in them is hopefully less harmful. So examples, using email instead of paper, using web pages instead of brochures, and home working, which we're all doing right now, at least in the fall of 2020. A circular economy. Typically, we've been using a linear economy, which means the product is created, used, disposed of. In a circular economy, everything that comes into the economy stays in the economy until it can be safely used for something else or discarded with in a way that's not just sticking it in a hole in the ground, like we call a landfill. An economy model in which the resources remain in use as long as possible, from which maximum value is extracted while in use. Products and materials are recovered and regenerated at the end of the product life cycle, and hopefully reused for something again. On the bottom right, there's a nice visual that explains what the circular economy looks like versus the linear economy. They both start with raw materials. The difference is the circular economy has no end. It just keeps on going. The linear economy is made for use and then disposal. At the bottom of this, you'll see underlined that last statement. How can this product be made to be made again? And that's really what the circular economy is all about. There are 3 central strands to the circular economy. Cradle to cradle, which really is being made to be made again, because it's the opposite of cradle to grave, which you created it was used, and then disposed of. You can also design for disassembly. If you have a product that's made of lots of different materials, it's hard to recycle that product. But if you design it to be disassembled at the end of use, it makes it a whole lot easier to either reuse parts or to recycle them. Biomimicry. This is kind of a newer idea, although I'm sure it's been around for a long time. But for the designer to look out into nature and find desirable traits, things that have already evolved on their own, things that are very efficient, that can be built into designs to make them even better. Because in nature, we typically don't find waste. Everything in nature is part of a cycle. Back to our circular economy. These are ways that your products, at the end of their use, might be able to be reused or recycled even easier. So smart memory screws. What those are instead of permanent fixtures holding your assembly together, these are screws that are easy to disassemble to get it into your product and pull it apart and take the different materials apart from each other. Adhesives and circuit boards that can be dissolved. That's what you're seeing on the left here. So when you're done with it, instead of all those components, some of which have really valuable materials in it, you can dissolve it away, separate them away from each other, and reuse them. Using clips rather than adhesives or screws so that they're less permanent, easier to disassemble, and using biological materials that can be safely returned to the biosphere with no toxic dyes or other materials. So when it's done, it'll eventually break down and rejoin a cycle. Circular economy, equal important, are the systems in which the products move globally. This is tricky. If you make a product and it's close to you when it's being used, it's probably easier for you to control what happens to it later on. If you make a product and ship it across the world, how can you make sure that it's disposed of or used correctly? So the quote is, how will the materials or components be recovered and made use of again? One way forward is to develop different business models where users buy performance through leasing rather than purchasing. So you return it versus disposing of it. It's kind of a reverse supply chain. Think of it like this. You want a car. You buy that car. You own that car. You're going to use that car for a certain amount of years. When you're done with it, you may try to sell it, but at some point that car is going to be too old and it's going to end up in a scrapyard. Same thing with your lawnmower. Same thing with your dishwasher or an oven. What if we just leased all of those different products? You leased it for a certain amount of time, and when it was no longer desirable to use, too old or had too many issues, you could return it and you would get a new one and you would lease that instead. When you return it, you're returning it to a group of professionals that knows how to maintain that product. They'll refurbish it, or if it's beyond refurbishment, maybe they'll just disassemble it and be able to reuse the parts in there that are still usable and recycle the rest. Here's our linear economy, which I probably should have started with because it's the best example of what we currently do with a lot of our products. We make it, we use it, we dispose of it. Linear versus circular. So on the left side, you see the linear. On the right side, you see the circular. We've already covered the differences. Here's a little video.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food. Energy is provided by the sun. Things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components, and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
All right. So the Throwaway Society, that's a nickname that to the United States and Australia tends to get clumped in with us. The two of us in particular have been kind of deemed um, because we've gotten to a point where manufacturing is so efficient and so cheap that it's easier for us to just when a product wears out, instead of replacing it, we just throw it away. We go buy a new one. And what that means is a lot of really good, valuable materials end up in a landfill. So we need to see if we can change that. At some point, you have to wonder if those landfills have such valuable materials in them that we'll be using those, the final statement says right here, as a source to mine resources from. Okay, so here's a couple key terms. They come from IB. Reuse of a product in the same context or in a different context. So reusing a product. Recycling refers to the use of materials from obsolete products to create other products. Repair, the reconstruction or renewal of any product of an existing structure or device. Recondition, rebuilding a product so it's as new in an as new condition. Car engines are known for this, and tires also. Re-engineer, to redesign components or products to improve their characteristics or performance. Use and recover of standard parts at the end of their product. So maybe this is called upcycling. Maybe this is what we need to do with a lot of our old microchips that we have on circuit boards. Recovery of raw materials. Strategies for the separation of components of a product in order to recover raw materials.
The world's population and prosperity is on the increase, whilst our primary raw materials are dwindling. As a result, industry is extracting as many materials as possible from waste. As for complex industrial waste, Indaver separates this into its different molecular groups. Innovative techniques make it possible for Indaver to isolate scarce and valuable molecules such as iodine and palladium from complex industrial waste streams without compromising on quality. This allows us to reuse rare materials in industry. The waste that remains is processed according to the strictest safety requirements. Closing the loops in a circular economy.
All right, international mindedness. The export of highly toxic waste from one country to another is an issue for all stakeholders. And this is a true thing. This happens. Countries with more money don't want to deal with their waste, so they will send it to other countries. They'll pay for it, but it's worth it to them, the amount they're having to pay. The country with less money, it's worth it to them to take the waste because they need the money bad enough. So this does happen in our world. Theory of knowledge. The circular economy can be seen as an example of a paradigm shift in the design. Does knowledge develop through paradigm shifts in all areas of knowledge? And our standard. The exploration of possible solutions to eliminate waste in our society has given rise to ideas developed as part of the circular economy. By redesigning products and processes, the waste from one product can become the raw material of another.